All right, guys, let's look at our last way to solve our quadratics here. I just kind of want to give you a heads up for the rest of the week. Like I said, this will be our last skill before we're heading into our test. Tomorrow, I'll probably give you'll be getting the study guide. Make sure you're looking over that, asking your questions, because probably the way we're going to do an assessment, I'm going to the test will be unlocked on Friday. You'll have the weekend, and I'm also probably going to assign the same thing on Monday as well. So you have 2 whole class periods to get that test into me, because the quizzes, I'm still scrambling for a lot of you all to kind of turn those in. All right, so the last skill that we're going to talk about here is being able to solve our quadratics by taking square roots. And we can do this when they are of the form ax squared plus c. Notice, in our traditional standard form, we have the ax squared plus bx plus c. When we have this extra little x term in here where it comes, where the b usually hangs out, you cannot apply this skill here, okay? So when the bx term is gone, we can take our square root. So if we look at our first example here, we're looking at x squared is equal to 36. We can kind of look at this and say, well, this is asking us some number squared is equal to 36. Well, I know a lot of y'all can kind of see that in your head and say, well, I know that 6 squared is 36, but there's also another number we can square to be 36. And that number is a -6, right? Because -6 times -6 will also give us a positive 36. So the other note I kind of want you to jot down with this, whenever we take the square root, you need to remember to take the positive and the negative case. Okay, and like I said, just kind of a quick rundown again, because there are 2 numbers that we can square that give us the same positive squared value of a 36, right? And so, again, I know you all could probably sit here and do this in your head. What 2 numbers can we multiply to get 36? But you need to start thinking of, what undoes a square, right? So if we're squaring a value, the opposite of squaring something is to square root it. So when we see this x squared is completely on a side by itself, this allows us to take the square root of both sides. Hence, this is the skill today, being able to take the square root of both sides. And in doing so, again, whenever we square root a value, whenever you take the square root of an equation like this, okay, so the square root of x squared is x, the square root of 36 is 6, but it also, like I just told you, remember, right, it is also -6, right? Because -6 times -6 is also a positive 36. So whenever we take the square root of a value, you need to remember to take the positive and the negative case. All right, so I have about 6 more examples with you. Once you kind of get the hang of it, this is kind of what's I think is nice about these NTI days. Once you kind of got the hang of it, you're ready to move on, go on. Okay, you don't have to listen to the whole video, but I will be going through like 7 or 8 examples. So if you still don't feel like you got the hang of it, then hang on with me here. So we got x squared is equal to 18. Okay, so this one's a little bit different because, well, I don't think there is no number that we can think of that multiplied by itself gets 18. Well, using the quadratic formula, we have been able to simplify our square roots a little bit, okay? So we've got an x squared on the side by itself, okay? So we have the positive case here, x squared, square root of x squared is x. The square root of 18, we don't know what number square root of 18 is, so we're just going to leave it here, the square root of 18. But everything that we've been doing here, you need to remember to simplify. Okay, we did an entire unit on being able to simplify a radical, right? There's a perfect square that goes into 18. It's 9. So the square root of 18 is the same thing as saying 3 radical 2. But like I said before, there's a positive case, and x is also equal to a negative radical 18. Okay, there's a positive and a negative case. And again, we need to simplify. And this kind of simplifies the same way, but now we've got a negative on the outside with it. So again, when we're talking about quadratics, okay, you should always anticipate those two solutions. Let's look at a skill that, we talked about in yesterday's lesson. So what if we see that, I don't know, let's say x squared is equal to negative 10. Okay, so again, this is asking us what number can we multiply by itself to get a negative value? Well, we should know that when we multiply two negatives to each other, right, it's going to give us a positive, and obviously two positives gives a negative. So there is no real solution here, right? We learned that the other day with finding the array or finding no real roots. Okay, this is going to kind of be the same situation. So to undo this, I'm going to take the square root of both sides. Okay, case number 1, well, that's going to be x is equal to the square root of negative 10. Okay, and before we would say, well, this isn't a real solution, right? Well, the other day's lesson, we talked about our complex number. We looked at to what it means to be an I, right? So remember, I is the same thing as saying a negative 1. So I'm going to branch this out a little bit. So this same thing is saying this, negative 1 times 10. And like I said, the other day's lesson, we learned that, well, negative 1 is I. Okay, well, that's the first case. And then again, we can take our second case here. So x is also equal to the negative square root of negative 10. We're going to break this down the same exact way. Okay, that I is going to now come out, but now it's going to be a negative I radical 10. And then again, always look to simplify your radical, but the square root of 10, that does not go down any further there. All right, a couple more here. Let's getting a little bit more complex here. So let's say we have 2x squared is equal to, I don't know, let's use that 10 again. Now, again, this definitely is still in the same form of ax squared plus c. There's no bx term in here, but we need to be careful. We can't just jump in and take the square root, okay? If we jump in and start taking a square root here, now we're taking a square root of a 2. We're taking a square of an x squared. This thing gets a whole lot uglier pretty quick here. So kind of the skill we need to talk about here is understanding that this 2 is stuck to the x squared by multiplication. So what I want to do is I want to get that x squared to a side by itself. And understanding that that's stuck by multiplication, I'm going to undo this by division. Okay, so now we're going to be left with x squared is equal to, on the right side, I've got 10 over 2, which is 5. Okay, so now we have that squared term on the side by itself. Now I'm going to go ahead and take the square root of both sides. Okay, so now when I take the square root of both sides, now this allows me to separate my two cases. Again, the first case, the positive case, the square root of x squared is x. The square root of 5, I don't think 5 can go any further than 5, right? 5 is a prime number. So x is equal to 5. And we have the negative case that the square root of x squared is x. And now it is also equal to negative 5. Okay, so always remember your two cases. You've got a positive case, you have the negative case. It stays true to regardless of how it looks. Okay, so maybe getting a little bit more complex here. I'm going to do 2 more examples with y'all. A little bit about this guy. Let's say we have 3x squared minus 4 equals negative 1. So again, maybe your thought process goes, well, this is equal to a negative value. We can't square something to get a negative value, but understand this x squared is not on a side by itself yet, okay? So we don't have something squared is equal to a negative 1. Okay, so we've got to do a little manipulating. We've got to take care of our algebra skills to get this x squared on a side by itself before we can take the square root, okay? So the first move I'm going to do is I'm going to add 4 to both sides. Okay, so that's going to leave me with the 3x squared. On the right side, I have negative 1 plus 4, which is 3. And now this, again, just like our last example, this is stuck by multiplication. I want to undo this. by division. So those 3's are going to go away. Now I'm left with x squared, and x squared is equal to 3 over 3, which is 1. All right, now we have the x squared on the side completely by itself. So this allows me to now take the square root. Again, first case, right, the positive case, square root of x squared is x. And we have the square root of 1. Well, 1 squared is 1. And the negative case, x is equal to negative square root of 1. But the square root of 1, again, is 1. So we have two solutions here that x is 1, but also x can be a negative 1. All right, so one last example. I think this is probably the hardest ones that you may come across. I know the assignment that goes along with this is in Delta Math. I know that Delta Math examples that I have for you definitely have these kind of hanging out. All right, so let's say x plus 2, all of this squared. So this comes from vertex form that we've dealt with for a lot of this semester. The a x minus h plus k. Okay, so this is very similar to that form that we've been looking at. But, you know, we're not trying to find vertex, so this doesn't help us. We need to find solutions. So, again, okay, we need to take the square root of both sides. And notice that this whole thing is being squared. So before our examples where we just saw an x squared, now we've got a plus 2 on the inside. We can't subtract this 2 away. Okay, this 2 is inside parentheses, so this 2 is being raised to a squared power. Okay, we just can't pop him out of the parentheses. So actually kind of makes it a little bit easier because since this whole thing is being squared, well, I'm going to take the square root of the whole thing. Okay, so I'm going to take the square root of both sides. All right, so when I take the square root of the whole thing of x plus 2 being squared, the squared goes away. So then you're just left with case number 1 being x plus 2 is equal to radical 11. And that was case 1. Case number 2, again, we have x plus 2 is equal to the negative radical 11. So the first thing I would look to do or try to see if I can break down that radical. 11 is a prime number. 11 does not go any further. But again, remember, you're being asked to solve, right? Or if you're being asked to find the root here. Okay, so we've got to get x on the side by itself. We've got one little minor step left. We've got to subtract 2 from both sides. So that's going to leave me with this x. Remember our radical rules. You know, only when we're combining like terms, the radical has to be perfectly the same. This isn't even a radical. Okay, so this first solution is going to be negative 2 plus radical 11. Typical form, the radical is written last. Any kind of whole number you may have gets written first. Same situation that's coming over here. I want to subtract 2 from both sides. So x is equal to, we have that negative 2 now minus the square root of 11. All right, so hopefully these help you. Again, if you get confused, you know, reach out. Again, this is our last skill kind of leading before our test, so you definitely need to make sure you're kind of keeping up with this. If you're struggling, please reach out to me. All right, there you go, guys.